Okay, this is Brian with Ion Electrical, and we completely rewired a old historic house here that's brick. And so yeah, today let's show you what's involved in if you're going to rewire an old house with a project of this size and magnitude. So go on ahead, let's go. What can we point out first? First is it's an old historic house. It's got, I'm going to say hardwood floors, but they're probably just pine. Nevertheless, it's solid wood. 9-foot ceilings. This place has pocket doors. There's a factory down the street, by the way. And along this street, they built a lot of nice houses, probably with those factory workers in mind. Moeller, Oregon, right up the street. Maybe some of you have heard of Moeller, Oregon. But anyway, with that said, here we are, 100 years later, or 70 years later, and this is what we did to put all new wiring in. I'm the third electrician that was called in. They kind of threw some money away on some bad guys that promised and talked but couldn't come through, and hacked up the place a little bit. And so we came in and did it proper for obvious reasons, for safety, etc. So we're in the foyer. A lot of electricians maybe would suggest instead of cutting the walls open, you run wire mold on the walls, but we cut the walls open and ran all new Romex wire. At the switches for the lighting, you're going to see all white wire. That's 15 amp wire, 14.2 Romex. The yellow wire down here, that's 20 amp wire, and that powers the outlets. So of course, you have to follow the National Electric Code when you do a wiring project, and it just covers the minimum. We did over the minimum on the houses we wire, whether they're new or old. Each room, each bedroom, living room, I always put the outlets on their own dedicated 20 amp circuit. The code requires this. We're in the dining room, so obviously the code requires it to be 20 amp wire on its dedicated circuit, which it is. Here's something else you have to do too. We already put these outlets on and they're working, by the way, but they have shutters in the outlets now, tamper-proof for children. But anyway, we opened this is opened up this wall here, because above here is bedrooms, and then the attic. Made this kind of a main wire chase to get circuits up to the second floor. Each room we did, there again you're seeing a hole there where the first electricians tried to put a light fixture box, and I just went ahead and moved it to the dead center of the room, and they're already working. That's a plastic box, but it is paddle fan rated for up to a 75-pound paddle fan, or a 150-pound light fixture can go on there. There's the switches for that. Again, they had the 4 foot to the bottom of switches is a standard height for switches. So I went ahead and moved those to the proper height. You're seeing a 2-gang box here. They make that a paddle fan. You can put a second switch to control just the fan and keep the light working by itself on the first switch. Down here you're seeing a quad outlet. You don't have to do that, that's not the code, but I went ahead and did that in this corner. For convenience, over here we did a triple. Again, that only has to be a single, but I did a triple here because that's a big handhold to reach in and fish a wire. On this outside wall on the front porch is a outside receptacle, so I can reach my hand back in there and get that wire and pull it out of the wall easy. and now they have a triple outlet, and those are very convenient, by the way. We didn't do the outlets on the walls over there yet for the rough-in electrical, because when they come back for the final inspection, they'll see pieces of wire mold that come up and hit an outlet. We can get that from the basement. Here, there's an old floor outlet. We cut and deleted all the old wiring. Over here is, went ahead and cut the ceiling open over here. There's a wire chase. Get wires to the switches, the outlets, etc. Of course, the front doors over there, we had to drop wires down for that. That's a smoke detector. We have smoke detectors in all the rooms per code, all tied together. Let's look up while we're looking at the front door here. This looks like it might be towel, but it's not. It's some kind of board there, but went ahead and cut a 3-gang box in the wall there. If you'll notice, that 3-gang box that's in the wall is a normal nail-on for new work. You just trim off the edges and sink it in the wall. You put a back on that box, a standoff. I just use bottle caps. That'll keep the box from pushing in the wall. And to keep it from pulling out of the wall, you just put drywall screws at each corner that stick through, and the way the box can't pull out of the wall now. They sell old work boxes at Lowe's, Home Depot. They show it in the how to do wiring books. But those boxes have ears that make the devices stand off the wall. And not to mention the box itself is smaller. You can't get as many wires in for dimmer switches and stuff. We don't use those. So now these devices fit on the wall real flush. The plate will go on there real nice without any troubles. Let's go out here in the kitchen. We got together before they did anything, and this is the kitchen. They were wanting to surface mount stuff on this masonry wall, and I was like, no way. Frame out a wall. You can insulate it as well, and then of course it makes the wiring of your outlets. And there's the lifer over the sink. We got provisions for a disposal as well. Not to mention it made a easier to chase wires to the second floor. You can see some of them. We opened the ceiling there to get wires up there. Over here, we had to open this all up to do the kitchen switches properly. Look here, 2 and 3 gang boxes are nice. Even this is just going to be a spare switch here that we can blank off later during the final. We only need 2 switches. There's a switch for the light over the table there in the corner of the kitchen, and then of course the normal ceiling light. All this stuff is already powered and working, which is what you can do on a new house or a remodel. You'll notice here too that the wires that are coming up don't just come in the bottom of this box. We like to take them up over. If you bring all your wires either in the top or in the bottom of a box, instead of mixing them, it just makes it easier for putting the wires and the wire joints back in. It makes it easier. It gives a little courtesy loop in case in the future you ever have to redo something there. What else can we show you? Let's go upstairs. Why are we seeing that? That's where the first crew of electricians just broke open the wall with their hammer. Pulled some wire in. Of course, hacked it up and did it wrong. We yanked all that out. It's another sad story. We might put this in the nightmare section of my website as well, and the fire hazard section. But we yanked all their wire out, the brand new wire, reused what we could of it. because they pulled it in such a horrible fashion. It was just ripped and tore in a lot of places. As you can see, they cut open the ceiling up here to do lighting, and we didn't need to do that. Above us here on the second floor is the third floor attic. We just tore the floor up where we needed to get wires in. And again, we got when you're doing something like this, especially just pick a room in an old house, and it's great if you have it to yourself, and the carpenters and drywallers and plumbers aren't all here at the same time. You can get a lot more work done that way. A little bit of good planning goes a long way in remodel. So here we are. This is a nice room. You don't see this a lot in residential. If ever, in 35 years, I've never seen anyone do it, but to save a little money, we bought EMT and 4 squares and RS covers, and just installed that. These are masonry walls, thick masonry walls, 2 layers of brick. Thick is how these walls are. I chose to put it up here on the masonry, on the paint, plaster on top of masonry, by the way, instead of down here, because if I could have put this mounted into the wood baseboard here, but that sticks out into the room a little further. Kind of gets in the way of when you set your furniture around and stuff. So another advantage to this the 4 square and EMT is you can change this RS cover and put a quad outlet in here real quick and easy if you wanted to. Over here is the beginning of the run. The Romex comes in the side of this steel box here. This is a normal framed wall here, and the power started here. This was an existing, the first electricians had a wire here, so I just went ahead and left that. Piece of Romex comes through the wall and shoots in the side of this box, and that begins the EMT run, outlet run around the whole wall here. Front wall masonry as well. And this is the divider wall. There's it's a duplex house, so there's a rental unit next door. So even though this isn't masonry, I kept the tape in there for the last outlet. What do you see in here? A mistake? The switches are behind the door instead of over here on this side. Well, when I got here, they already had a switch cut in up high here, so I just went ahead and kept them on this side. And there again, there's a spare in case they hang a paddle fan in this bedroom, and it's a paddle fan rated box. So rather than tear the ceiling open or use wire mold to drop down to this, you like switches as you walk in the door to be right handy. But we didn't do it in this room. That could be done later if they want to. You can surface mount wire mold over and hit the switch. But then again, they might get new doors and just hinge the door that way, as it should be when you enter a room of this size. But anyway, that's the only room where we did that. Here's another bedroom we're in, and again, I keep the lighting circuit on 14.2, which is 15 amp rated, which would work out to roughly 1600 watts of power you could use on a 14.2 15 amp rated circuit. And with today's lighting, you now have 10 watt screw-in LED bulbs that equal 60 watt of incandescent. So there's no problem keeping your lighting on 14 gauge wire in residential, which is what we did here. 14.2 is also easier to work with and put the switches and devices on later. We got paddle fan rated box boxes again. If you look up there, you'll see where the old gas pipe, when they had gas ceiling lights. The outlets are all on 20 amp wire, which is 12-2. If you're the inspector and coming in, you'll see all the wire. It's dated and everything. And the wire's color coded now, so it's easy to identify it, what the amperage of it is, not to mention the date, manufacturer, etc. But the wall was already open here. We went ahead and just nailed on new plastic side nailer boxes for the outlets. If this wall wasn't open like that, I probably would have cut a chase up high and dropped the wires down and did it that way. But since the wall was already open here, we just went with it. We didn't use, here's a hole that's drilled near the front of the stud. And when we got here, they had wires passing through these holes right here, which is too, that's a fire hazard. So I drilled all new holes, lined up straight. And here's some feeders that are going up to the attic yet, coming from the first floor below us here. You can see down there we went ahead and put some fire stop in the holes for code. The holes that penetrate through the floors are chimneys in a fire. So per code you have to fill them up with a fire block, fire stop. This is foam TV wire here. Just took a regular side nailer box and cut the back out of it. Nailed it onto the stud because it's low voltage. You don't need to have a back on your box. So when you come to mount that plate, wires will just push back in there, no problems. The switches were mounted here in this bedroom. Of course, we were yanking out the junky boxes they bought, and the wiring was all bad. So I went ahead and nailed the switch back on here. Well, it turns out that the hinges of the door are here. That means this door is going to hinge open and cover these switches, right? That's no good. So I just left it there and tapped the spare wire from there up into the attic and dropped it over, and the switch is here now. So now you're covered. You can, when the paint and drywall work's all done, I can just blank this off and keep the switches here where they need to be. But if when I get here, the door actually does swing this way, my bases are covered. You can put the switches here, right? So, there you go. Again, this is an old house. Back when 2x4s were actually 2x4s. Today's 2x4s are 1.5 inches by 3.5. Back then they were 2 by 4 inches. They framed this wall flat ways, so I was able to find a 3-gang just by chance, shallow enough plastic side nailer to get in there. I chose a 3-gang for this room just to get more room for all the wires. So they'll have a ceiling light, paddle fan, and we'll just blank that third one off.
I sneezed.
Again, the history of these old houses. They painted the wood floor here, sand that off, and shellac it up. It'll look awesome, yes. Yeah, I did a quad outlet in this bedroom as well. There's we did dedicated phone TV runs to each room per code. This is the rear wall of this bedroom. So I got my tape measure out, and again the code, the 6-foot rule to the first outlet from the edge of this door needs to be 6 feet. I was able to use the studding here to get an outlet in the corner and didn't have to put anything on this masonry. Did a quad outlet here on this wall. And then over on the outside wall, it's masonry. I was gonna maybe go up in the attic and drop wire mold down for pipe since we're using EMT. Instead I went to the kitchen that was below this room and the ceiling's already open. So I just dropped it into the kitchen and went over and brought that wire up right there for looks so you don't have to see a pipe and anything here on the wall. Went in the attic for the, and dropped down for power for the rear porch light, which is here. Again, we used 4 squares and RS covers and EMT. EMT, maybe $2 a stick. If you choose to use the painted wire mold, it's $10 a stick. And then the wire mold boxes are, $5 a piece. A 4 square here might be 60 cents for the box and 60 cents for the RS cover. Again, you can change these RS covers. They'll pop right off and you can put in a 2-switch cover if for some reason you need a second switch here for a spare light or something, or a floodlight on the rear deck. So what do we got here? The masonry wall. We went ahead and put a, they call these bubble covers. You can pull out these tabs. That's the extension cord coming through that little notch, and you can plug it in. And when you close the cover, the plugged in cord is now rainproof. Okay, here we are on this really nice historic house again in the attic. And as you can see, even the attic has a tongue and groove. I don't know if this is hardwood, or I wish I was more of a wood expert, or if this is just pine solid wood. I'm calling it hardwood. So this is what you do, what you can do. There's different ways to wire old houses. Some ways obviously being better than others. This, what we like to do is take the floor up and then drill holes to get the new wires to the respective rooms, bedrooms that are below here. So all this floor has to go back. To get it up, you bring your Sawzall and your hammer and pry bars. Take your time and do it right, and you won't damage the floor, and you can put it back and sand it and hardly even tell it was up. Each board that I took up, I put a number or a letter is on the one end of the board, and then I wrote it too on the floor joist so that you won't get your boards all. Here's one that has the number 5 on it. There's some old wiring. Someone had the floor up before. This is very scary looking. So you can see they just notched the floor joist and put a real weird staple in there. Over here it is again, passing through that hardwood. Talk about a fire hazard. These old houses, you have to keep in mind, dry lumber. Everything's dry. It is fuel for a fire. Thankfully, they have arc fault breakers now, and if you professionally install your wires so that they're not a fire hazard and someone's not going to come back and run a screw through the floor and into the Romex, you have less of a fire risk. Every electrical system is inherently a fire hazard, but if you do it proper and professional, that risk is at a bare minimum. Here we are in the second floor bathroom. The door isn't on, and it hinged this way, but they have framing for a tub here now. So, like I did that one bedroom, I have a switch on each side of the door. So my bases are covered. When I come back, it doesn't matter how the door hinges. The switch will be on the right side. There's where the spare switch should go. I marked it and capped it off there. Over here's there's going to be 3 switches: a vanity light, a light over the shower, which I just turned on. It's already working, by the way. It'll make it very convenient for the painters and the plumbers. They'll have light to see to do their job. That's a can light over the shower. You call them can lights, you need recessed lights. You can now just get 10 watt LEDs and they're shower rated. You don't have to buy a special shower rated lens or anything anymore. And then there'll be, we went ahead and cut a bath fan in the ceiling there as well, which will be vented to the outside. There's the box for the light that's going to be over the vanity. I like to do quad outlets. This is going to be the vanity, and the code requires a receptacle. I went ahead and put it on this side of the vanity. Some people set things, phone charger or something, you'll have a plug here for that. If they ever wanted to, with the attic the way it is, you needed to fish a wire on this side of the vanity, they could do that later. This is just going to be a rental unit. So. Alright, this is Brian with Ion Electrical Systems, and we're on a rewire of an old historic house and going over some things. Right now we're going to talk about what is the heart of every electrical system. That would be the service. So the heart of every electrical system is the service. So let's look over here where the old service was in this basement. It's the little 10 circuit panel, and there it is. We've yanked all the wire out of that. It's dead now. We've installed a new service, and the city has passed inspection and they've energized it. We put it over here on the outside wall. Again, how do you fasten a service to a stone wall? Drop down some treated lumber, put some marine grade 3/4 plywood up, and set your 200 amp panel. The main breaker, we used a 42 circuit. They have these in 54 and even I think 60 circuit. But 42 is the minimum size breaker box you want on any house these days. And went ahead and put a convenience outlet that also, by the way, is a nightlight, glows in the dark. This isn't to code, this is a convenience toolbox. Because this is a rental unit, and they might be putting a sub panel here, maybe turning the second floor into its own apartment or something, and a pool box would come in handy for that should that day arise. We do all of our services in pipe. You can see the services fed with a 2-inch PVC pipe here that goes out to the meter, and then from the meter we'll go outside and see that in a minute. It goes up to the weatherhead. This is a city job, so the service is overhead. Look here, you're looking at, this is the new 2014 code is enforced now, pretty much nationwide. Actually, it started back in either 2008 or 2011. You had to put these, what's called AFI breakers, arc fault rated. And they trip out if they sense arcing. You know, an extension cord is arcing, or it's sparking at the plug or the device in the wall. Maybe children are messing with a receptacle or something and making sparks. These things will trip out for safety, prevent a fire. So all lighting and receptacle in residential now has to be arc fault, which we did that here. We labeled it. Again, 3/4 plywood. This has got a nice sanded finish on it, marine grade. That's the way to do things. Over here, if first electrician crew just nailed up a little board here for the new service they were going to put there. Again, they got the city came in and shut them down, and we got called in to do it right. This is the outside portion of the electrical service. We were just in the basement in there. So here's the new 200 amp meter, and the pipe goes through the masonry wall into the panel there. Here is a inter-system bonding termination block. You take that screw off there, there's ground points for when they put the phone cable boxes and all. They need a place to ground to. That's the code. Now, we do our services in pipe, because this the wire that feeds this meter and then that runs into the breaker is unfused. It goes right out to the pole, and hence it's unfused cable. So we like to put it in pipe. Not to mention you could paint this pipe a red or something to blend in with the brick. If you're up, your workers are up working around the windows or something and banging their ladders into the pipe, it won't matter. It's very durable, so it's safer. It's the way to do services. Over here, if you look at the house right beside us, there's as you can see, that's just unfused cable out in the open, and it doesn't look good, but this cable can get a little cut in it, and then boom, there's the water coming in it. And we've seen it happen. Water will start funneling in and corroding the terminations. The water can even follow it into the breaker box if the cable's routed in such a way that it takes it right in. We've replaced whole services because of that. Pipe's the way to go. You can avoid all that. You're spending your hard-earned money. You want your electric service to be safe and work. Not to mention it adds value to your house and the property. Let's get back here. So we had to bring the ground wire. You can see it coming out underneath the deck here. We brought it down this post here. I went ahead and covered it. It's a copper wire. Kids are coming around or something, they won't snip it, steal it or something. Kind of, that pipe kind of deters that. So there's a couple ground rods here to ground the electrical system. You can't see them. We went ahead and buried them already. Good job. The old meter and stuff. Here it is. All that's going to go. And again, the electrical system's heart is the electrical service. That's what we have just been talking about.